Good evening, everyone. Myself, Neeraj Ranakoti. I am Research Associate in AIMS Research and I am moderating today's session. First of all, I warmly welcome you all to the hands-on workshop, Statistics Made Easy Basic to Advanced Biostatistical Online SPSS Series Season 2. Today marks day 6 of the workshop. The topic to be covered today are displaying on your screen. Without further delay, I would like to invite Dr. Ashok kindly begin the session. Over to you, sir.
Thank you, Neeraj sir. Thank you. Good evening, all participants. So, without wasting time, I should start, because if I start early, then I'll finish in time. So, my screen is visible, sir?
Yes, sir. Visible, sir. Visible.
Okay. So, this is day 6. You can see here. So, first of all, we will plot a scatter plot. So, when we do correlation, and correlation between two quantitative variable, height, weight, BMI, age, hemoglobin, quality of life and age. Okay. So to plot these variables, we should use, or we have to use a scatter plot. So in x-axis, there is a independent variable, and in y-axis, there is a dependent variable. Now we will discuss about simple linear regression versus multiple linear regression. So it is for prediction. It is like next step after correlation. Then repeated measure ANOVA, analysis of variance, with post hoc analysis for multiple comparisons. And if your dependent variable is quantitative and repeatedly measures over time period, for example, in your study, you are measuring quality of life. Okay. There is one group, 100 participants, and you are measuring quality of life at baseline, at 3 months, at 6 months, okay, or at 1 year. So it is a repeatedly measure. So to compare mean quality of life, okay, between baseline to 1 year, or baseline to 3 months, baseline to 6 months. So we will use this repeated measure ANOVA. If our quantitative dependent variable is normally distributed. If it is not normally distributed, so we should use, or we should go for Friedman test. Okay. And then we will use McNemar-Bowker test. McNemar or McNemar-Bowker test. For example, it is a like McNemar-Bowker test. It is a pre and post design, pre-design, post design, before and after design. Okay. So in this, for example, if participant, for example, have pre, there is we will assess pen. Okay, pen yes and no format, binary format, pen yes, pen no, pen yes, pen no. Okay, and any symptoms yes and no. Then after treatment, or after intervention, or after 6 months, or 3 months, or 1 year, we will assess again pain. Okay, yes and no format. There is whether there is a pain or not. Yes and no of same participants. So this is a dichotomous. Yes and no. This is a dichotomous. So for this, we will use McNemar test. But if it is like more than 2 category, for example, pain is mild, moderate, and severe, and after 3 months, same patient, we will assess pain level, mild, moderate, and severe. So if there are more than 2 category, okay, then we will use McNemar-Bowker test. McNemar-Bowker is the extent of the McNemar test. How we will use, we will discuss. So this is, we have already discussed about this parametric versus non-parametric, famous slide. You please remember this. If we use only before and after, or pre and post, and one group, only 2 times, Okay, before and after, pre and post, 1 month or 3 months, only 1 month and 3 months, only 2 times. And dependent variable is quantitative, single group. Dependent variable is quantitative. So we use, if this quantitative variable is normally distributed, we use dependent or paired t-test. If it is not normally distributed, we go for Wilcoxon sign test. But there is one group, but there are repeatedly measured more than 2 times. For example, baseline 1 month, 3 months, 6 months, more than 2. If repeatedly over 2 times, it is repeated only for 2 times, then we have to go for dependent t-test or Wilcoxon, whether it is normally distributed or not normally. But if it is more than 2 times, okay, repeated, then we have to go for, if this dependent variable, quantitative variable is normally distributed, we should go for repeated measures ANOVA, or if it is not normally distributed, we should go for Friedman test. So you can remember this situation. Okay, for example, patients, any patient, hypertensive patient, okay, cancer patient, and we measure their quality of life at baseline, then 3 months, and then 6 months. So it is a more than 2 times. So we use either we go for repeated measure ANOVA or Friedman test according to normalcy. Then this is same or one group or within group. It is also before and after, baseline to follow up. Okay, there are 2 conditions, but here there is, what is difference? Difference is about dependent variable. In this case, our dependent variable is binary outcome. Okay, only binary, yes and no. For example, pain. Any condition, yes and no, present abscess, disease present, disease present. Mortality, yes, mortality, no. Okay, or improvement, yes, or improvement, no. In this condition, if we want to compare this situation from baseline to 3 months, then we have to use McNamara test. But if same patients, okay, same condition, but there is a before and after situation, baseline to follow-up situation, but the outcome variable has more than 2 categories. For example, disease symptoms, mild, moderate, severe. Pain level, mild, moderate, severe. Before baseline, at baseline, or after 1 month or after 3 months. Okay, or that is not and or. So when we compare baseline to 3 months, and there are more than 2 categories, it is called McNamara-Bowker test. In SPSS, no need to go for like McNamara-Bowker and McNamara separate. There is only one command. So automatically this will give sometimes McNamara test or McNamara-Bowker test result. So we will discuss about this, okay? Now, simple linear regression versus multiple linear regression. There are a lot of questions regarding this yesterday. So you have to remember that if your dependent variable, you can see here, this is a dependent variable. Your dependent variable is quantitative, okay? And you want to predict about your independent variable is quantitative, and you want to predict your dependent or outcome variable on the basis of this independent variable. And your dependent variable is also quantitative. For example, weight, systolic BP, income, creatinine level, hemoglobin, like quality of life, etc. So your independent variable is quantitative, single, and dependent variable is also quantitative, single, okay, only single. Then we go for simple linear regression. Only, for example, height, weight, age, quality of life, age versus quality of life, height versus weight, BMI versus age. So it is called simple linear regression. But for example, dependent variable is only single, but there are more than one independent variable. There are more than one independent variable. For example, hemoglobin, it is our dependent variable. But independent variable is, we can say, age, systolic age, gender, BMI. So if independent variable is more than one, so it is called multiple linear regression. Okay, but our dependent variable must be one and independent variable more than one. Then we have to go for multiple linear regression. Okay, then output results, simple and in multiple linear regression, gives us result in the form of beta coefficient and p-value. Then we have to make one regression line. I will show how to make. Okay, so you have to understand about simple versus multiple linear regression. So simple linear regression is y is equal to a plus bx. This is a equation line, regression line for simple linear regression. Or weight in kg, y, what is y? Y is equal to weight in kg is equal to a is constant plus b is also constant. Multiply by, this is x, height in centimeter. So this is equation I have made for example. So weight is dependent on height. So this is equation. To predict the change in quantitative dependent variable weight. So what is change? By change or manipulation in only one independent variable. It is called only one independent variable. It means simple linear regression. So it is also called univariate or bivariate linear regression. Okay. As we know that weight is not only depend on height. We know that weight is not only and only depend on height. It may also dependent on other independent factor. For example, age, gender, socioeconomic status, nutrition level, occupation, etc. These variables are called confounding variable. In this situation, they are called confounding variable because we want to see effect of height on weight. So in this condition, these variables are called confounding variable. Although we can perform univariate simple linear regression for each independent factor or variable separately, like we can do simple linear regression, weight versus height, weight versus gender, weight versus age, weight versus occupation. We can do simple linear regression multiple times and get regression equation for each factor separately. And also we can get coefficient, beta coefficient or coefficient of determinant, that is a R square value. Okay. But these above result are crude result, not adjusted for confounding variable. So these are crude result, these are not filtered result. So we cannot conclude that how much like height affecting weight. Okay, how much purely height is affecting weight, because there are some other confounding variable and we are not adjusting. So for adjustment, we have to use multiple linear regression because we see effect of height on weight after adjustment of other variable, after controlling other confounding variable. For example, age confounding variable. So I will control age, gender, socioeconomic status, and occupation and nutrition level. And I just see only and only effect of height on weight. So I have to go for multiple linear regression. So multiple linear regression, but we only want to see effect of only height on weight. I want to see effect of only age on HB. Okay. Other variable I want to ignore or I want to adjust. I want to control. So other variable are maybe confounding variable. Okay. So I will use multiple linear regression. Pure height and weight relation after nullifying or adjusting the effect of other confounding variable like age, gender, and occupation or whatever, nutrition level, okay, something, or and socioeconomic status, etc. So we have to adjust the effect of other confounding variable, which is not possible in simple linear regression equation or model. So we have to use multiple linear regression model if our dependent variable is in quantitative in nature. For example, weight, for example, HB, for example, quality of life. You can think anything. For example, systolic of BP, if this is your dependent variable. Okay, and you want to see effect of age on systolic BP, but you want to nullify or adjusting the effect of other thing, for example, age, gender, say gender, occupation, and something else, socioeconomic status, medication history, disease history. If you want to controlling those confounding variable and you want to see only effect, purely effect of age on systolic BP, then you have to go for multiple linear regression. Okay, so let's have fun with SPSS to find out the independent predictor. These are called independent predictor. For example, age is independent predictor of systolic BP, or age is, if my dependent variable is quality of life, then socioeconomic status is independent predictor of quality of life. Or in this case, to find out the independent predictors of HB level at baseline. So what is HB level? And this HB level is depend on which variable, independently which variable. Okay, we have to find out in a multiple linear regression. We do simple linear regression. After that, we will do multiple linear regression. So equation of multiple linear regression, you can see it is y is equal to a plus bx. In this condition, there are many x. Okay, for example, age, BMI, okay, gender. In this condition, so we have to write down y is equal to a is a constant, plus b1 x1. Okay, b1 is a beta coefficient of x1. X1 is here age in years, you can see here. Or what is y is HB. Okay, B2 is a beta coefficient for gender, and here gender, what is gender? Male is equal to 1 or oblique female is equal to 0. So what is 1 and what is 0? We have given coding 1 to male and 0 to female. So we have to remember coding also in this condition. If you have given coding male 1 or female 2, you have to write down. Okay, that time if you want to multiply, how multiply I will show you. Then we have to use male for 1 and female for 2. But in this condition, if I want to multiply for female, I have to use 0. Okay, then it is beta B3, that is a beta coefficient for BMI, and it is like kg per meter square, we know. And plus, if there is any other variable, n type of variable, we can add here with the epsilon. It means there is an error, we can ignore this. It is a random error. Okay, so you have to remember this. In simple linear regression, there is a y is equal to a plus bx. But in multiple linear regression, it is y is equal to a plus b1 x1, b2 x2, b3 x3, b4 x4, b5 x5, bn xn, up to n variable. Okay, so we will start now. So first, scatter plot. So I have opened already. Okay, where is, oh sorry, I have to, this is practice data sheet 6. I have to click this. I have to send this in WhatsApp group. You can open. It is opening. Okay. So first, I will show you how to do a scatter plot. So scatter plot between two quantitative variables. For example, HB at baseline and age. Okay. So what I have to do, this is graph, and just next to analyze, there is a graph button. You can see, click this, then go for legacy dialogues. Okay, and then you have to see where is scatter plot. This is a scatter or dot plot. Okay, graph, legacy dialogues, and dot plot. Please click this. This window will come. So for simple, like only two variable, so we have to select this simple scatter. Okay, it is already selected. This is a highlighted with the like square black, okay, lines. Then click define, and click define. This will come. This dialog box will come. Simple scatter plot. So in y-axis, you have to enter your dependent variable, and I want to see effect of age on HB level baseline. So y variable is my dependent variable HB or independent variable age x-axis. So here is age. You can see, you can click this age and then you can click this arrow just near to x-axis. Okay, just click. So it will you can say it came here age. But here y-axis I have to enter HB base. So where is HB base? I can scroll down here. This is HB base, and then click HB base and then click this arrow here. Okay. After that, there is no need to do anything. Just click. If you want to give title, this is a title. You can see in the right hand. You can see there is a title button and option button. You can click. You can give title, but there is no need of this. Okay. And option, there is no need of this to do anything for this option. Then click continue. Then click OK. Then you will get this type of graph. It is called scatter plot. Okay, you can see I'm not getting which type of. Okay, so it is like negative or positive. I'm not getting. Okay, so what I have to do, I have to, because I know that in perfect positive or perfect negative there is a line. Okay, there is a line. You can say straight line. Like a up down up line and one is down line, but it is not clear from this scatter plot. So what I have to do, I have to click double, because here you can see double click to activate. So I have to click double and activate it. So please click double. It is activated. Okay, it is activated now. You can do any changes in this. So you have to see in this, this is a chart editor. Then you have to see this is here. Okay, data label option, show data label, and here this is a add fit line at total, add fit line, best fit line. It is a regression line. Okay, what is it? It is a regression line. So please click this, and this line will come. Okay, it is from upward to downward. You can see it is upward to downward. You can see it means there is a negative correlation. If it like positive correlation, then this line will go from downward to upward. Okay, and it is not straight down, upward to downward. It is, you can say there is a slight slope from upward to downward. So it is a, there is weak or mild correlation, and that is a negative correlation. So I can see correlation also in this. Okay, I want to see correlation, exact correlation. So this is a line of best fit. It will give automatic. You can see here, this is a R square. You can see here, this is a R square. Coefficient of determinant. Okay, this like right side of this chart editor. And it is a 0.041. It means if we converted into percentage, it is a 4.1%. So it is very, very less, because there is a no significant correlation. So it is very, very less. Age affecting variability in HB. Age of the participants affecting variability of HB in HB hemoglobin by only 4.1%. 0.041 means 4.1%. So 96% thinks others, they are affecting HB level. So we can interpret according to this. And you can see this is y is equal to 14.8 minus 0.04 multiplied by x. You can see here, this is a equation line, simple linear equation. This is a simple linear equation line. You can see. Okay, so I can cross it. I can do anything for this, close it. Okay, then I can cross it. This is a scatter plot with the regression line. What is it? You can see here, what is like here you can see age is 30, 40, 50, 60, 70, 80, 90. It is not started from 0. It is started from, I think, like 30. So it's a 25, something like that. Okay. So we have to understand this. It is not starting 0. And what is it here? what do you mean by intercept? When this regression line cross y line at x is equal to 0. So it is called an intercept. And what is intercept? This is intercept 14.8. You have to remember that is a 14.8 is the intercept. And what is a 0.04 minus 0.04? It is a slope. Okay, it is a slope. It is in minus. Minus means there is a like negative correlation. Now we will go for simple linear regression and we will understand about this. So for simple linear regression, what I have to do, I have to click analyze, then regression, and then linear. Analyze, regression, and linear. This is a simple linear regression. Please click this. Okay. This will come. Okay. This is dependent and independent. This is linear regression. This is dependent and these are the independent. So what I have to predict? I have to predict HB baseline. It is my dependent variable. So I have to put this HB baseline, click here, and then go to you have to click this arrow. Okay, if I click here, so it will come in independent variable. And if I click here, so it will come in dependent variable. And I know that my HB baseline is my dependent variable. Please click here. Then what? Then in independent variable, I will bring age. So please click here on age and then bring this arrow. It will come. So when because in linear regression, simple or multiple, there is only one dependent variable. But if there is only single independent variable, it is called simple linear regression. If more than one independent variable, it is called multiple linear regression. So suppose if I put age in this, click sex, okay, sex in this sex, and then I will click this arrow. When I put in independence, two variables, okay, so it is called multiple linear regression. But only if I put only age in this, so it is called simple linear regression. Okay. So for multiple linear regression, I can put many variables what I want. Okay. So I can put. So how to do simple linear regression first. Then you have to see this statistics button. So please click this statistics button here. And in statistics button, there is a linear regression statistics, and please click this confidence interval. It is a beta coefficient, 95% confidence interval of the beta coefficient. This estimate is a beta coefficient. And then click descriptive also. No need to do anything in this. Okay. Then click continue. So what? Estimate is default. You have to click this 90 confidence interval. For 95% for estimate, you have to click a descriptive. Model fit is coming, okay, default. So you have to click a descriptive, then click a continue. Then no need to do anything. This is a method of this regression analysis. Enter method. There are some other stepwise, remove, backward, and forward. So most popular method is enter. Please select this, okay. Then click OK. Then this regression analysis will come. There are 150, and this is a mean and SD of HB baseline and age. This is a correlation matrix. You can see here there is a correlation matrix, and I want to see correlation matrix. I can see here there is a Pearson correlation between HR value HB and age. This is a negative correlated, minus 0.202. It is a mild negative correlation, okay. And what is p value? This is a significant one-tailed. It is a one-tailed, but we should go for two-tailed. It is coming 0.007. It is highly significant, and in two-tailed will become significant also, okay. So age is significantly correlated with the p like HB baseline. So age is increasing, so HB is slightly decreasing. You can see here. This is variable enter or removed. We are using enter method. We have entered method, so it is coming here, enter. This is model summary. You have to report. You have to report this method also. We use enter method in simple linear regression. or multiple linear regression. In model summary, we also use this is R square and this is adjusted R square. So this is, you can see this is R, okay, and this is R square of this R. This is coefficient of determinant and this is adjusted R square. So please go for adjusted R square, okay. So you can, so it is coming down. 0.041 is R square. It is adjusted R square is less than 0.041. It is 0.034. It is 3.4% variation of HB among HB in due to age. Okay, it's very, very small. This is ANOVA table. Okay, and we have to see this p value of ANOVA. It is coming significant. P value, SIG, that is a p value. It means this model is a significant. If it is not coming significant, it means this model is not significant. We cannot use this model. That is main thing how to interpret this ANOVA table. It is coming significant because it is less than 0.05. So it is, this model is significant. So we can use this model, and this is coefficients. This is main table. So you can see here, we have to always use this unstandardized coefficients. It is B. B means beta coefficient. Please use every time this unstandardized coefficient. Don't use standardized coefficient of beta, okay? So we should use for this. This is a constant. Constant means A. A is a constant. Y is equal to A plus BX. So A is constant, okay? It is 14.802. And this is, okay? And what is? This is plus B into X. X is here age. And what is B? B is minus 0.035. So we can say, we can make a, like a, we can make our equation like this. You can see here, we can make equation like this, okay? So we can say Y is equal to A plus BX. So what is AY? Y is equal to HB. So HB at baseline, you have to write down baseline is equal to, what is A? So I can see here in output, A is a 14.80. So I have to write down 14.80. Okay. Then 14.80. Then I have to put a plus. Then I have to write down minus, because there is minus 0.035. So I have to write down minus 0.035. Then bracket close, then multiply by age in years. This is my equation. Okay, so when we open this bracket, so how can I write down? I can write down, okay, I can copy paste it. I can write down here. If I open this bracket, I can write down this. Or if I like round figure this is 0.034, I can round figure this 4. So it is coming like that. This is a simple linear regression equation. You can understand using this model. And this is why I use this, because you can see here, this is SIG. It is a SIG means P value. It must be coming significant. Then I can make this like a line, equation line. Suppose it is not coming significant, it is 0.013, it is significant. Then I can make this model. Otherwise, I cannot make this model. If suppose if this age like cannot come significant or is not significant, the p value is greater than 0.05, then I cannot make this equation, because there is no significant relationship between age and HB. So you have to make this equation only for significant variable. If there is no significant, please no need to make any like linear regression equation. So I can see here, I can calculate, suppose if one person age is 60 years, okay? So what will be HB at baseline using this equation? So I can predict it. So what I have to do, I have to click this, I have to copy paste this. I have to write down here age is 60. So I can write down here 60. Okay. Then I have to, and then you can calculate also. So this is 60 multiplied by 0.04. So what will come? I think it will come around 2.4, something like that. Okay. 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 It means like 2.4, something like that. You can see here 2.4. I can use calculator, no issue. Then calculator is here. You can see. So 0.04 multiplied by 60. 2.4. Very good. So it is 2.4. Then what will happen? I can calculate HB at baseline. I have to minus this 2.4 from 14.80. So it will come 12.40 milligram per DL. I can say using this equation. So it is called simple linear regression. Okay. Thank you. Then we will go for multiple linear regression. So what I told you, I can like enter other dependent variable in this. So this is recall recently used dialog. Click this, then go for linear regression. Same command. Click here. Then this is, I have already entered it. So just entered gender and BMI. Okay. I want to see effect of age, sex, and BMI on HB base. Okay. So click this. Okay. There is no need to do anything. And I know male is equal to 1 and female is equal to 0 here. Okay. So click OK. So this will come. You can see here. This is highly significant model. ANOVA, you can see here. This is adjusted R square is increasing from 0.03 to 0.188. It means 18.8% combined effect of BMI, age, and sex on HB. Then you can see this is a coefficient table. Okay. Then I will make this like equation, multiple linear regression using this table. You have to see all are significant. So, okay, all are significant. Age is significant, sex is highly significant, and BMI is highly significant. And okay, and then this is a constant. And I use this unstandardized coefficient, then I use this p-value. So how to make this? Please click here. I will make this. So I will copy this. I can copy this, okay? I can make this from here to here. Okay, I can copy this. So what I have to do, this is HB. I can make this. This is HB at base. You have to write down. This is HB at base. What is A? A is, you have to see. A, what is A? A is a constant, 11.25. So you have to write down 11.25. Okay, just. What is B1? B1 for age. B1 for age minus 0.27. So I can write down B1 in bracket minus 0.27 means 3. Okay. And multiply by age in years. Okay. What is B2? B2 is, you can write down, B2 is gender, 1.35. You can see this is for gender. Okay. 1.35. Multiply by gender. Gender, male is equal to 1, female is equal to 0 already. Okay, very good. Then what is B3? B3 is for BMI, 0.087. So I have to write down 0.087. I think this is multiply. And BMI is in this. Then there is none of other variables. So I can. So this is my equation I got in a multiple linear regression. I can predict it. Okay. I can predict, for example, I can predict if a male patient, okay, and BMI is this, mean BMI, because I have controlled BMI, so mean BMI. So I have to calculate mean BMI using my frequency, okay. Then I can calculate. So on mean BMI, male patient, age is 40. So what I have to do, suppose age is 40 years. Okay. Then male patient. So male is equal to 1. You have to remember 1. Okay. Then for BMI is, suppose this is mean BMI is around 23. Okay, 23 BMI. So for this I can calculate HB using this formula. So I can put all these things here. Then I can calculate. Here mean BMI I have to write down because I want to see effect only age. So I have to write down mean BMI. So 11.24, this one age in years, age is 40. So I have to put 40 here. Okay, I have to put 40 here. Then gender is equal to for male. So what I have given, male is equal to 1. So I have to put 1 here. Please remember this. I put 1 here. If it is for female, I have to put 0 here. And when it will be multiplied, it will come 0. So this is beauty of this like simple linear or multiple linear. And BMI is mean BMI. That is came 23. Suppose it is came 23. Then I can predict this HB at baseline. Please do this equation and you can get age 40 male patient and at mean BMI. Okay, you can get this HB. Okay, this is multiple linear regression. Okay, now go for repeated measure ANOVA and Friedman. So I think it will take 5 minutes more. No, not take much time. So you have to understand this simple and multiple linear regression. Okay. So save. Sorry, don't save. Sorry, don't save. Then go for multiple linear regression. So this is a multiple linear regression beta coefficient. These are the beta coefficient. These are the p value. Suppose this BMI will not come significant. So you cannot write down in a model. You have to remove from that model. You have to then put age and gender only. Okay. So which variable came significant, you have to put in model. Otherwise you cannot put. Okay. Now go for like repeated measure ANOVA. So I want to compare HB baseline, HB 3 month or HB 6 months. Okay. Mean comparison. What is relationship of these? Okay. So what I have to do, I have to go in data, then I have to click analyze. Then I have to go in general linear model. Please see, this is a general linear model and this is a repeated measure. No. Analyze general linear model and repeated measures. It is repeated measures ANOVA. So please click this. Very good. This will come. Please see this carefully. This is within factor, within subject factor. So in factor, what you have to write down? Please, you have to write down time, T-I-M-E. Always write down time. Okay. And how many times? Baseline, 3 month and 6 month. So there are 3 times. If it is 1 year, there are 4 times. So in this case, there are only 3 times we measured HB. Okay. So I have to put number of level 3. Then click 8. So time in bracket 3. Now measure name means HB. Okay, then I have to click add here. Please remember this. HB, I have to click on measure and then add. Please don't forget to add. Okay, then click define. So please click define. This dialog box will come, repeated measures. Very good. So here you can see this is a within subject variable time and this is a between subject factor. If you have group, 2 group, you have to like bring that grouping variable here. Okay. So these are, if you want to there are some covariate means other like significant confounding variable you want to adjust. For example, in covariate here, you will put only quantitative variable, age, height, weight, BMI, something like that you can put here. But I will show a simple example over. So I want to compare mean baseline, 3 month baseline and 6 month baseline of HB. There is a comparison. Okay. There is one group. If baseline quality of life, 3 month quality of life or 6 month quality of life, whatever you want to assess, and repeatedly measures, more than 2. If there are only 2, 1 month and 3 months, then you have to go for Petri test. So where are my HB? Okay, here HB. I can click on HB base, then shift and down arrow, then click here. So these all 3 HB base, HB 3 month and HB 6 month came here in this within subject. Then you have to click this post hoc. You have to click this EM, estimated measure of mean. You have to click. So please click this, and you have to bring overall and time from here to in display mean. So please select these both and then click this arrow, and these will like you can see they came here. Then please click this compare man effect. When you compare man effect, this like a line or highlighted, you can see here. If you don't click this, it's disappeared, not highlighted. When you click this, and then when you click L, and you have to please click this LSD and select Bonferroni post hoc measurement, most popular method. Click this, then click continue. For post hoc analysis, every time you will see Bonferroni. Okay, then click option. This is option button. Please click, and here is a descriptive statistics, and this is a estimates of effect size also. Okay, if you want to click power, you can click this power. Okay, then you click continue. If you want to click homogeneity test, you can click this. Then you can click continue. So in display, in option, you have to click in display descriptive, estimated of effect size, observed power, and homogeneity test. You can click continue. Then you can click OK. So this is for your repeated measure ANOVA, general linear model, repeated measure ANOVA. So you can see here, this is the time 1, time 2, time 3. You can see here, time 1 is baseline, time 2 is HB 3 month, and time 3 is HB 6 month. These are the mean and SD of 3 month, baseline, and 6 month. You can see from baseline to 3 month, it is increasing. But after 3 month to 6 month, it is decreasing. Okay. You no need to see this multivariate test. There is no need of this. You have to see this test, Moseley test of sphericity. So please remember, if Moseley test p value, this is p value. Okay, you just see this. SIG means p value. In every test, if there is a SIG, it means significance. It is a p value. If this Moseley test p value is greater than 0.05, okay. If this Moseley test of p value greater than 0.05, although it is less than, but I'm like giving example of greater than 0.05. So what you have to do, you have to see this test of within subject effect. You have to go for sphericity assumed. Okay, because if it is test Moseley test of sphericity. So if it is greater than 0.05, same as normalcy check. Okay, so if it is greater than 0.05, it means sphericity is assumed. Otherwise, it is not assumed. So in this condition, we have to go for corrections, and most popular correction is greenhouse geyser correction. Okay, so we have to take p value, f value, and degree of freedom from greenhouse geyser correction. So you can see here, this is geyser house correction. This is SIG. Oh, SIG means p value of this repeated measure, overall p value. Okay, and what do you mean by at least two pairs? At least two pair have significant difference. Okay, which two pair? Baseline to 3 month, or baseline to 6 month, or 3 month to 6 month? This table cannot say. So for this, we have to go for multiple comparison, Bonferroni correction. So please see this. So I see that Moseley test of sphericity is less than 0.05. It means there is a violation of the sphericity. So I should go for greenhouse geyser correction, and I will take a SIG p value. Okay, 0.061. It is not coming significant. So you can see here, without looking at this, I think we can go directly sphericity assumed by mistake, and I will take this p value by mistake. Oh, it is coming significant. Yes, but actually it is not coming significant due to this violation of the sphericity. And when I see mostly test of sphericity, it is coming less than 0.05. So I have to take greenhouse geyser correction. Okay, and this p value is coming greater than 0.05. It means at 3 point data point or time point, baseline 3 month and 6 month, there is no significant difference, okay, among HB level. We can conclude according to this, okay. But by mistake, if I took this p value, sphericity assumed p value, it is coming significant. Okay, so this is a type 1 error. You can see here type 1 error and type 2 error. Type 1 error is reject the null hypothesis when it is true. So what is null hypothesis? There is no significant difference. What is alternate hypothesis? There is significant difference. Same, okay? So reject the null hypothesis when it is true. So what is null hypothesis? There is no significant difference. Okay. So when I took this sphericity assumed, it means there is a significant difference, but actually there is no significant difference after seeing this greenhouse geyser correction. It means if I take this sphericity assumed p value, it means I am making a type 1 error. And what is type 1 error? Reject the null hypothesis when it is correct. Okay, so I'm making this mistake. So please remember this, don't make type 1 error also. Okay, so suppose, for example, suppose if this p value came greater than 0.05, then I have to take sphericity assumed p value and it is coming significant. Okay, in this condition, another condition, okay, in another condition, then I cannot say that, I can say that there is a significant difference. Okay, maybe HB baseline to 3 month, baseline to 6 month, or baseline 3 month to 6 month, but I cannot say in which pair it is coming significant. So I have to go for post hoc analysis. So where it is coming below this. This is a pairwise comparison, and you can see adjustment for multiple comparison Bonferroni in footnote of this table. So this is time and time. This is time 1 means baseline, and this is time 2 is a 3 month. This time 3 is a 6 month. I can compare baseline to 3 month, and this is coming p value. It is not coming significant. When I compare 1 to 3, baseline to 6 month, then this p value is coming. It is also coming not significant. Then 1 to 2, it means 1 to 2 or 2 to 1, same p value you will get. And 2 to 3, you can see it is 0.057. It is trend, you can see here, less than 0.1 p value. It's coming trend, but it is not coming significant. So, and 3 to 1, okay, this is 0.422 p value. So I can say here, when I did pairwise comparison using Bonferroni correction adjustment p value, there is no significant between baseline to 3 month, baseline to 6 month, and 6 month to 3 month. I can conclude according to this. Now only 2 minutes. This is repeated measure ANOVA. Then I will go for Friedman. Suppose my HB variable is not normally distributed. Then I have to go for Friedman test. Okay, for repeated measures ANOVA, repeated measures, I have to go for Friedman. So where is Friedman test? I have to click analyze button. Then I have to go for non-parametric. All non-parametric tests will be here. Okay. Then I have to go for, because I need multiple comparison. Okay, pairwise comparison, multiple. So I have to go this related sample. Okay. There is also in legacy dialog, there is also 2 related sample or K related sample. K related means this is a Friedman test. two related sample means this is a Wilcoxon signed rank test. Two independent sample means there is a Mann-Whitney test. K independent sample means this is a Kruskal-Wallis test. Okay, we have to remember. But for this, I have to go for related samples. So click this related samples. This window will come, dialog box will come. So what you have to do, you have to click this field. Then you have to enter in test field, you have to enter HB baseline, HB 3 month and HB 6 month. Please enter from here to here. Then in setting, please click setting. Then you have to click a customize test here. Okay. Same as you can remember for Kruskal-Wallis we did. From separate tab we use this. And then you have to click comparison distribution. You have to click this. Friedman's two-way ANOVA by rank. Okay. Multiple comparison all pairwise. Okay. Then please click run. Okay. So field, you have to enter all these test field. Okay. Then in setting, you have to click this. First, you have to click, it is default setting. So you have to first click customize test. Then you have to click this Friedman, all multiple comparison, then click run. Then you have to see what is coming. Okay. So this is coming. So this is a reject the null hypothesis 0.025. Okay, so this is Friedman overall p-value. At least between two time point there is a significant difference, but which time point it is not showing. So for this, what we have to do, we have to double click it, double click to activate. So please double click. In like 30, if you get full like overall this type of analysis, so it's very good. Otherwise, you have to double click this. You can see it is for overall p-value of Friedman test, but we need compare like pairwise comparison. So what you have to do, you have to click this related sample test. Okay, this is below this above this taskbar. There is a related sample test in view. You please click this, and then you will get a pairwise comparison. So when you click this pairwise comparison will come. Then you can see this is adjusted significance p-value. HB base, okay, and HB 6 month, there is a comparison. This is p-value of adjusted and unadjusted p-value. SIG, this is a unadjusted. But when we see adjusted p-value, SIG means adjusted p-value, Bonferroni adjusted, this is 0.300. It's not coming significant. HB baseline to 3 month, you can see in unadjusted, it is coming significant. But in adjusted, it is not coming significant. There is trend. You have to see. At 6 month to 3 month, it is this p-value is not coming significant also. But in adjusted, it is also not coming significant, 1.00. It is called Bonferroni correction for multiple comparison. So what we can conclude? We can conclude if we apply and we applied Friedman test for repeated measures of hemoglobin at baseline 3 month and 6 month, and when we compare it, so and we apply Bonferroni correction for multiple comparisons, so there is no significant, we can say, according to comparison of the pairs. Okay, but overall p-value is came significant. But when we do multiple comparison, adjusted p-value, it is not coming significant. So we have to report this. We have to report with median and IQR and p-value of this overall Friedman test and p-value of this pairwise adjusted p-value with Bonferroni correction. We have to make in tables, and I will show how to make tables in last day. Okay, so please see that session of last day, how to make table in Word file of these analysis. I will demo on last day of this. So we have done this. Okay, I can copy and paste this. Okay, there is no problem. You can see there is a button of copy. You can see copy visualization. You can see here. You can copy and paste this copy visualization from here. Now for 5 minutes, I will take a McNemar and Bowker test. Okay. So only for 5 minutes. So for, as I told you that McNemar and Bowker, there is a categorical or qualitative variable before and after. There are only two situations, before and after. And if it is dichotomous, qualitative or categorical variable dichotomous, then I will use McNemar. Or if it is more than two category, for example, mild, moderate, severe, or any other condition, then automatically this SPSS will give McNemar-Bowker test. So how to do? So please, I can see here in my data sheet, there are outcome. Outcome is 3 month and 6 month. 1 is improvement, 0 is not improvement at 3 month. And at outcome at 6 month, 1 is improvement and 0 is not improvement. So I can do if there is a significant difference 3 month to 6 month in this binary outcome, 0 and 1 binary. So I know that it is a McNemar test I can use. So click analyze, then click descriptive, then click cross step. Okay, it is only for 2 minutes, not more than 2. Cross step. Okay, analyze, descriptive, and cross step. So please click this. Then what you have to do? You have to go your variables. This is outcome 3 month and outcome 6 months. So please remember, last outcome means 3 month, in 3 month and 6 month. What is last outcome? That is at 6 month. So please bring this outcome 6 in column and outcome 3 month in a row. Click this and you can bring this. In chi-square test, we did it. Okay. So what you have to do? You have to click this outcome 6 month. Then please click this column. You have to bring in column. So please click this arrow. And in outcome 3rd month, click this and you can bring in row. So this is a difference. Okay. Then exact, no need to do exact because we are doing a McNemar. So please click statistics. If you click exact, no, you can click, no problem. You can click on exact, you can click this. This is because for cross step or chi-square, always please select this exact. So I selected this exact, no problem. Okay, continue. Then on statistics, this is chi-square and this is McNemar test. You have to remember this is McNemar. Then click continue. And then in sales, you can click on percentage, row wise, column wise, or total. Whatever you want, you can click. Okay, so I click on column. I prefer column. But if you want to click on row, on total, you can click. Then click continue. So I know that in 3 month and 6 month, there is only 2 category: improvement, non-improvement. So what will come? It come McNemar test. Otherwise, it is more than 2 category, it will come McNemar-Bowker test. Okay. Then click OK. Then you can see here, this is outcome 6 month. This is outcome 3rd month. So please remember this. I will explain you. This is 0. 0 means at outcome 3 month, 0 means no improvement. This is 1. 1 means at outcome 3 month, there is no improvement. At 3 month, there is no improvement. Here, this is at 6 month, 0 means no improvement. 1 means there is improvement. Okay. So see here, 3 month improvement, no improvement. So there are how many in total who did not improve? 112 out of 150. Okay. 112 out of 150. The percentage is given here, you can see. Okay. And in 1 month, how many improvement? 38 out of 150. The percentage is given here. Now you have to see 6 month. 0 means no improvement. So here 102. Okay. And then improvement, you can see 48 improvement at 6 months. And you can see at 3 months, there is 38 improvement. But in 6 months, there is 48. So there are improvement in 10 more participants, 10 more subjects. At 3 months, only 38. And at 6 months, there is a 48. So this improvement is statistically significant or not. You have to see this McNemar test. Okay, you have to see McNemar test. You no need to see Pearson chi-square, Fisher exact test. You have to see McNemar test. It is same patient, follow for 3 months and 6 months, binary outcome, automatically it come McNemar test. If it is more than 2 outcome, for example, mild, moderate, severe, here mild, moderate, severe, then you will get here McNemar Bowker test automatically. And this is p-value. You have to use exact significant two-sided p-value, 0.002. Always use this, please. Don't use one-sided. Always use two-sided. So I can write down at 3 months, there are 38 patients. It means 25.3%. Okay. Participants were improved. And at 6 months, 48 participants were improved out of 150. Please calculate okay percentage, because I just calculated only column percentage, not row percentage. So out of 150, 48 participants. So please calculate percentage. And at 3 months, out of 150, 38% like improved. Whereas at 6 months, 48. So there is a difference, and this difference is significant or not, statistically significant or not. How can we tell? We can tell using this McNemar p-value. Oh, it's coming highly significant. So p-value is a 0.002 with McNemar test. We can say according to this. Okay. But if you want to do this McNemar test according to group, for example, if you have control group or experiment group, 2 group, and you want to see within group 3 months to 6 months. So what you have to do? First, you have to split file and you have to do this test. So again, I'll do split file. How to do split file? Please click data. Then this is a split. You can see data and split. Okay. Then this dialog box will come. Then I have to click this organize output by group. Please click this. And then where is my group 2 here? Okay, group 2 code, control or intervention. Okay, in group 3, there is control, diet and yoga. So I'll choose this control and intervention only. Then please bring this group 2 code from here to group based on here. Then click OK. Okay. Then repeat this test. Okay. Then repeat this cross step. Then already we have like done, choose what we have to do. Then click OK. Then you can see it is in control group and it is in a intervention group, separate. You can see here it is for 150. Okay. This is for 150 overall. Here we did not separate, we did not split here, but here we split. And what you see it is only 75, because we have 75 in control group, 75 in experiment group. Then you can see here in control group, this is a control group, and in control group at 3 months, this is one is improvement, 12 out of 75. Okay, this is 16.0%. And at 6 months, 16 out of 75. So there are 4 more improvement here. 4 participants were improved compared to 3 months. It is coming significant or not? We have to see McNemar test. We have to see McNemar. It is not coming significant. 0.125. It is not coming significant. Yeah. But in intervention group, we can see here you can see at 6 months. You can see here at 6 months, it is an intervention group. You can see in 3 months, there are 26 patients improved. And in 6 months, there is 32% improved. So it is also only, I think, 6 patients improved. And over there, only 4 patients. So this 6 patients means 2 patients more improved in a intervention group. Okay. So we have to see this improvement is significant or not. Oh, it is coming significant. You can see McNemar test. And luckily, I got this significant. So I can say in control group, there is no significant improvement from third month to 6 month. Okay, but in intervention group, there is a significant improvement from third month to 6 month. And with these percentage, I can conclude or I can write down my result. Okay, hope you understood. Thank you very much. Thank you.
Thank you, Ashok sir, for such a wonderful session.
Thank you, ma'am. Thank you. If you have any question, participant question, they can ask me, no issue.
I think everyone present in today's session is now no more NOVA in applying ANOVA.
Okay.
That's why I am not seeing any query in the chat box except
Okay.
one.
Okay, yeah, you can.
One or two. In one query, participant is asking in version 30,
Mhm.
there is no split file option in descriptive statistics. What to choose?
Which option?
In version 30 of SPSS, there is no
Mhm.
split file option.
Okay, what option? Pardon?
Split file option
Split file option. There is no split file option.
in descriptive statistics.
No. It is in data option, or it may be in a descriptive. I will see. I will check, and I will like demo tomorrow. I will install 30 and then I will give. Okay, because right now I don't have 30. I have 25. So I think they can get split file in data. There is a data point, data button. Then they can click data and then they can get split option in data. Okay.
In
But
another question, a participant is asking if we have 3 dependent variable and 3 confounding variables, can
okay.
we use multiple linear regression?
No. That time, if you have 3 dependent variable, then you have to go for multivariate linear regression. You have to remember, if you have 3 dependent variable, okay, 3 dependent variable, then you have to go for multivariate linear regression. Okay, like for more than one dependent variable, you have to go for multivariate. But if you have only one dependent variable, then you have to go for multiple. So this is a difference between multiple and multivariate. Okay.
In another question, someone is asking, can we use chi-square for eliminating the effect of confounding variables?
No. We cannot use chi-square. We have to use like multivariate analysis. So like today I have shown you multiple linear regression. So if I want to show only if like effect of age on HB, then I have to nullify the effect of BMI and gender. Okay, and any other variable if I want to see. So like this tomorrow I will show adjust like logistic regression and Cox regression model. Okay, in that situation we can like control the confounding variable. In chi-square we cannot control. Okay.
In another question, someone is asking, during multiple regression calculation, you take male as 1 and how you take 23 as mean BMI or you take mean value of BMI?
Yeah, mean value of the BMI. Okay, I have to take mean value of the BMI. So I have to calculate mean BMI because time is short. So I just like assume that it is mean BMI of 23. Otherwise, you have to calculate mean BMI using SPSS. Then you have to take that mean BMI. Okay.
Someone is asking, can you explain again the steps of McNemer test?
McNemer test, I can explain. It is very easy. No issue. It is very easy. I can explain. Okay. Any other question? Then I will explain it. No issue.
There is no more questions in the chat.
Okay. Then I'll explain. Okay. No issue. So I will share this. No issue. I'll explain. Okay. Is it visible?
Yes, sir.
Okay. Then go for analyze, then descriptive, and then cross tab. Okay. Then click cross tab. So what you have to do? Okay. I'll reset it. This will come cross tab. So when we do chi-square, you have to go in cross tab, this dialog box. And for McNemer also, you have to use same dialog. Same command you have to use. Okay. Then you have to remember McNemar. McNemar means there is a pairwise comparison of qualitative variable, qualitative or categorical variable, pairwise comparison. There are only two situation, 2 times point. Okay. So in this condition, this is outcome 3 month and outcome 6 month. So as I told you, last outcome we have to bring in column, and other outcome we have to bring in row. This is I want to suggest. Okay, you can bring outcome 6 in row and in outcome 3 month in column. There is no problem. You will get similar p value. But I suggest that please bring last outcome measure in your column. Then what you have to do, you have to click statistics. In statistic, even there is no need of click this chi-square, because we are not doing chi-square test. Just click McNemar. No need to do, but you can click OK chi-square. It is our habit, so you can click continue. Then as I told you that it is our habit, so please click this exact and you click this exact. Why I follow these instructions? Because it is in our habit. So click this, and then do continue. Then cells. Okay. This time I will click row and column, both percentage. Okay. This time I click row and column. I select row and column. Then continue. And then click OK. Then this is overall I have splitted it. Okay. Already splitted. So it is in control group and in a intervention group. Okay. So this is, you can see here, there is a 75 patients. You can see here, and I want to see my outcome of interest. And what is my outcome of interest? That is a improvement. No improvement is not my outcome of interest. So I have to see only improvement. So what I have to see? I have to see at outcome at 3 months. 1 is improvement, 0 is no improvement. So what I have to see? I have to see at 3 months, I can see there is a 12% improved out of 75. Just I have to see. And what is the percentage? This is 16.0. You can calculate. 12 out of 75, that is 16%. And when I see outcome at 6 months, only improvement. So how many percent? 16% improved. So it is 1.3. Okay. Because I have calculated also row and column percentage. Okay. So it is coming like this out of 75. It is a 21.3%. Then from 3 months to 6 months, there is improvement of 4 patients, 12 to 16. 16.0 to 21.3. There is a difference. There is a difference. But this difference is statistically significant or not? I have to see p-value of McNemar test. Okay. So please don't go for Pearson chi-square. You can see Pearson chi-square is highly significant here. You can see here. Okay. But please don't go. Please don't confuse yourself. You have to go for McNemar test in this condition. And it is not coming significant. You have to take exact significant two-sided. It is 0.125. So in control group, there is at 3 months, 12% improved, 16.0%. Okay. But whereas at 6 months, 16% improved out of 75, that is 21.3%. And there is no significant improvement using McNemar test. Whereas in intervention group, you can see out of 75, you can see at 3 months, this is 1 is improved. You can see 26% improved at 6 months in 3 months. Okay, 3 months. At 3 months, there is a 26% improved, and that is in intervention group. That is 34.7%. Okay. But when we see at our 6 month improvement, this is 1, this is total 32% improved. And this is percentage is 42.7%. Right now, in this, I have calculated row and column percentage. So you can find out percentage. Okay. So this is, so here 26 and here 32. So there are 6% improved. So it is coming significant or not? Please don't go for chi-square test or Fisher exact test. Please rely on McNemar test, and it is coming significant, 0.031. It is less than 0.05. So I can conclude in control group, there is no significant improvement in from 3rd to 6th month, but in intervention group, there is a significant improvement. Although it is only 6%, but it is a statistically significant improvement. Okay, so we can conclude according to this. Okay, thank you.
Thank you, sir. I think we are done with all the questions in the chat box.
Thank you, ma'am. Thank
Once
you.
again, thank you so much for your time. And everyone present here, thank you so much for your presence and time. Thank you.
Thank you.